Systems of equations. What is a systems of equations looking for? A system of equations is looking for one thing and one thing only. The one point xy where the two lines cross. Now, this could be 3 lines or 4 lines or 5 lines. We're only going to be working with system of 2 equations, but you could have systems of 3 equations or 4 equations or 5 equations. But ultimately, the only thing any systems of equations is looking for is the one point where the 2 lines cross. So first, real quick, let's get into, if I have a system of equations that is 2x plus y equals -6, and my second equation is x plus 3y equals 2. And you are asked if the point -4, 2 satisfies the equation. Well, what exactly does that mean? Well, what that means is this the one point where the 2 lines cross? Okay, that's all that means. Is this the point where when you graph the equation number 1 and you graph equation number 2, is that the one point where these 2 lines cross? Well, you could graph these and see if that works, or we could do this. And you want to know how to do this. For the x, I'm going to put in -4, and for the y, I'm going to put in 2. So 2 times -4 is -8. And then -8 plus 2 is -6. So this means that this point for -4, 2 is on this line, but it's not the one point where the 2 lines cross unless it's on this line too. So in order to prove that this satisfies the equation, is the one point where the 2 lines cross, I have to check it in both equations. So I'm going to replace the x with -4 and the y with 3. And so I get -4. 3 times 2 is 6. -4 plus 6 is 2. And so my answer to this one is yes. Okay? Because these ended up being exactly the same. And this is how we can check any systems of equations when we do them for real. So let's do it again. 2x plus y equals -6, and our second equation is x plus 3y equals 2. And we want to know if 3 -12 satisfies the equation. So I just need to check it. 2 times 3 minus 12 equals -6. Well, that's 6 minus 12 equals -6. That's -6 equals -6. But remember, it has to work in every equation in the system. So if we only have 2, then we only need to check 2. But if I had 10, I would have to check in every single one, all 10 of them, because it has to work in all of them. Equals 2, so 3 minus 36 equals 2, and that's -33 equals 2. So the answer to this one is no. This does not satisfy the equation. In other words, this is not the one point where the 2 lines cross. Now, what we are actually going to learn is how to find these points ourselves. And we have 3 methods for how to do that. Okay? One method is we can graph. Second method is called the elimination method. Many people know it as the addition method. I like the elimination method title better because it helps me remember that I am eliminating stuff. And then we have the substitution method. But in every case, all we're trying to do is find the one point where the two lines cross. So I'm going to do three videos here. One showing you how to do the method of graphing, one showing you how to do the method of elimination, and one showing you how to do the substitution method. I may or may not need to do a fourth video because there is a couple of exceptions that we need to understand and know about. Maybe I can fit it into one of these. Okay, so first, let's look at our first equation. So here's our first example. And I like to do it like this, guys. Label your equations and then move them way over in the middle. And when I find that I do it this way, it really helps us out. If you're squishing everything up, it's really hard to know what's going on and to know which equation you're working with and all that. So this is the graphing method. Well, I need to get each of these equations into slope-intercept form so that I can graph them. So I've got this one, y equals mx plus b. It's equation number 1. So my slope here is -2. Remember, that's in my mind when I'm using this, it's going to be -2 over 1. Okay, and then my y-intercept point is going to be 0, -5. So now I will go to my graph. I should have written this down. So it's 0, -5, and -2. Okay, so I'm going to go to my graph and I'm going to graph that. Okay, so first I find my point. So 0, 1, 2, 3, 4, 5. And you notice I'm just working with the first line first. And then my slope, down 2 to the right 1. Down 2 to the right 1. Well, because I have no idea where these lines are going to cross, I want to get a few more points on here and make it big. So I can go the other way because I've run out of room here. So I could go up 2 and to the left 1, so a +2 and a -1, up 2 to the left 1, up 2 to the left 1, up 2 to the left 1. As long as I label 2 of my points, and the 2 points I need you to label are the y-intercept point and the very next point that you would get using slope. We'll label these things in a minute. Okay, that's my first line. So this was 0, -5, and my second point will be 1, -7. Okay, now I need to go back and do the same thing for my second equation because I have to graph them one at a time. So this will be, if I want to put it in slope-intercept form, and so this will be 1, oh my gosh, let's see, 1/3 x plus 2. So my slope is 1/3, and my y, well, that looks like a funny 2. My y-intercept point is 0 and 2. Okay, so now I'm going to go graph this line. And again, I have no idea where these lines are going to cross, so I have to make it big as well. So first I need to graph my intercept point, that's 0, 2, and then we go up 1 to the right 3, 1, 2, 3, up 1 to the right 3, 1, 2, 3, up 1 to the right 3, 1, 2, 3. Again, just to be on the safe side, I'm going to go the other way as well. So that would be a -1 and a -3. So down 1 to the left 3, down 1 and to the left 3, down 1 and to the left 3. Okay, so now I graph this line, and you want to use a ruler, and you've got to be very careful on these, because if you aren't careful, you could come into the middle of a box when in actuality the point is actually a whole numbers. But you could come into the middle of a box and then it looks like you've got a half or something like that. And again, label my point. So this one's 0, 2. And then the next one was 1, 2, 3, 1, 2, 3, 3. So when I'm graphing to find this, okay, I have to graph each line. I have to have at least 2 points for each line. And then I have to label the one point where the 2 lines cross. And this is going to be -3 and 1. Okay, now, so I know that the one point where the 2 lines cross is -3, 1. But let me check. So skip a line and check. And we're going to first equation, 2 times -3. Remember, this is coming from up here where we had the equation to begin with, or the system to begin with. Okay, so let's see, then plus 1 equals -5. So that's -6 plus 1 equals -5. And that's -5 equals -5. And then let's do it with the second equation. And that's going to be -3, because remember it was a -x plus 3y equals 6. So plus 1 equals, 3y. 3 times 1 equals 6. So that's +3 plus 3 equals 6. So 6 equals 6. So indeed, my answer is -3, 1. And that's how we graph. We'll go on to the next video, which will be the elimination method.